let's go to meet 6, event 5. So this event is on arc length and circular regions. So let's go and do the arc length. So if you have arc length is part of the circle. So let's say if you want to figure out like this part over here, the way to do this is go and figure out the entire circle. So the circumference of the circle is 2 pi r. So S is the part that the arc length you're looking for. So first you do the 2 pi r, that's the entire circle. Then you times by only a fraction that you want. So you only want this part, so you need to times it by theta over 360. Okay, if it's in degree. Now if it's in radian, then it will be 2 pi r times theta over 2 pi. And the 2 pi will cancel out after that. But again, use your common sense, use your logic to think it through. Okay? So that way it's easy to memorize the formula. So again, you do the 2 pi r, figure out the entire circle, then you times by only the fraction that you want. So if you want this part, then you times by theta out of total 360, or theta out of total 2 pi. And that's it. That's arc length. Super easy. Okay, now let's go and do the circular regions. So that's the area. So again, if you have a circle, two pi, and that's all you have to do. Again, first always figure out the entire circle, and you times only the portion that you want, and that's it. Super easy. Okay, all of you know this formula, all of you know this formula, then from there it's very easy to get the next part. Okay, so that's how you figure out the circular region. Now, if you have to figure out so this is called a sector. Now, if you figure out the area of a segment, a segment is this part right over here. This is called a segment. To figure out the area of a segment, again, it's not that difficult if you kind of understand the concept. The segment is equal to sector minus the triangle. So in other words, what you want to do, you want to develop your strategy. So this is equal to the sector minus the triangle. So you always throw out your picture, it helps you think through. So the area will equal to, now the sector is pi r squared times by the theta over 360, right? Minus the triangle. Now the triangle depends on, this one. This will be r, right? So, and you can use 1/2 base times height, right? The triangle. So you have to kind of able to turn the pictures one way or the other, figure out your base times height. Okay. And so that's it. Again, whenever you deal with this kind of area, you always, develop your strategy first. Then below it, you can use your knowledge to to do all that, and you can figure it out. Okay, another thing that's going to be very important is you got to know how to move things around, learn how to cut and paste. Okay, so if you go to 9091C, you have this picture that looks pretty complicated. But if you know how to do it, it's like it don't take you like a few seconds to do it. So you have, so let's go and do this. Okay. So this is 9091C problem. Okay, so you have this problem over here. It looks very complicated, how to figure out the area of this region. Okay. So it tells you that AB is equal to 4. So this is equal to 4. Now, if you know what to do, this is like super easy. Take you a couple of seconds to do this. Okay? So what you need to do is you need to know how to move these things around. If you move this out here, see this over here? So this is 2, and this is 4. So what's the area of the rectangle? 2 times 4 is 8, right? And you do that for 4 of them, so 8 times 4 is 32. That's your answer, right? So learn how to move things around. See, again, if you move these things out, right? So each of this is 2 times 4. Each of this is 8. So there are 4 of them. 4 times 8 is 32, and that's your answer. Okay? So learn how to move things around. It will help you to, solve things. Okay? Now, another type that you need to do is, if you go to the 86, 87, so go to 86, 87 C problem. For this one, you have this kind of that shape kind of I'm not even going to try this. So I call this cat eye. Cat eye is made out of 2 segments. So basically, your shaded region, okay, your area equal to a circle minus 12 times segments. Because each of these, if you cut in half, so whenever you see a cat eye, okay, I call it cat eye because it looks like a cat eye, right? Okay, so you can cut in half and it become 2 segments. So 1 cat eye equal to 2 segments. So there are 6 cat eyes. So you have to know how to use a circle minus 12 segments. Okay, so that's what you need to do. So now it tells you that radius is 6, right? So this would be pi r squared, right? Minus 12. Now this segment of here, this is going to be equal to that, and this would be, each of these with 60 degrees, right? And this would be, what's the radius? 6, right? So this is going to be equal to pi r squared times 60 out of 360, right? Remember, circular, right? Minus the triangle, the equilateral triangle. So again, this is equal to the sector minus the equilateral triangle. So equilateral triangle is 1/2 base times the height is 3 square root of 3, right? You have to know how to do that. And then you work it out, and that's how you get the answer. Okay? Again, I'm not going to spend time to work out the details, but I'm just going to show you the strategies. Okay? So you can draw your shapes and work it out. And that way you don't get confused. That's bad. Okay. So go to the one that says 3/89, the C problem. So it's this one over here. So you can notice that, so you count the number of cat eyes, 1, 2, 3, 4, 5, 6, so there are 12. So this one has the 12 cat eyes, so it means 24 segments. Okay, so basically area equal to 24 segments. So area equal to 24 times, so again, the segment came from the sector minus the triangle. Okay, so triangle. Now, in this case, the triangle is the 45, 45, is the 9, is, okay. So this one is, let's make a better shape. So this one, notice each one of these sector is this. Okay. Because if you look at that, right? So this is much easier to do. And it tells you that the square of each side is 8. So this is 8. So this is a 4, so radius will be 2, right? So this is 2. Okay, so area equal to 24 times, so the sector would be pi r squared times this is 1/4, right? 90 out of 360, so it's 1/4, right? 90 degrees, this is 90 degrees out of 360. Minus the area is 1/2 base times height. Okay, so this cancels out, so area equal to 24 times pi minus 2, and then you multiply out, so it's 24 pi minus 48. Okay? So again, if you know what to do, these are not that difficult, but if you don't, when you look at that, it's kind of overwhelming. Okay? So again, learn how to cut it down to the basic shapes. Okay? The segment is equal to a sector minus a triangle. Okay? From there, and then again, always write out your strategy. Write out your strategy, use the shapes, and from there you can line things up and you can match things up. Okay. Okay, another shortcut. Go to 8990. The C problem. Okay, it tells you that a circle is inscribed in rhombus. Okay, so a circle is inscribed in a rhombus. And it says the diagonal of the rhombus are 24 and 36. So this is 24, this is 36, so that means this is 18 and 18, and this is 12 and 12, right? So right away, you can use you can figure out the side over here. So, and you figure out from the area of the region inside the rhombus, but outside the circle. So you're looking for area of this right over here. So again, area is going to be equal to the rhombus minus the circle. Okay. And so from here, from this, right, you can figure out you can figure out this side over here if you want to. So you got 12, 18, and I'm going to call this, I'm just going to call it Z. Okay, I'm saving X for something. There's Z over here. So you can factor out a 6, so you get 2, 3. The reason you factor out, so it's easier to use Pythagorean theorem, the numbers are smaller. So a squared plus b squared equal to c squared, this will be 13, right? So 4 plus 9 give you 13, take the square root. So z will equal to 6 square root of 13. That way you keep your numbers small. So each of these is 6 square root of 13. So the area, the area of the rhombus is 1/2 d1, d2, right? Okay, so you need to know that. So area equal to 1/2 times 36 times 24, and so equal to 432. Okay, so you need to minus that. So you're kind of halfway there. So now you have to figure out the circle. Okay, now the circle, there are a couple of ways you can do this. Okay, to figure out the circle, since you already know the area, you can turn it sideways. So you can use 432 divided by 6 square root of 3, right? Divide by base will give you the height. And you divide by 2, you can figure out the radius of the circle. Again, when you turn a rhombus sideways, it becomes a parallelogram. Okay, so the area equal to base times the height. So use 432 divided by the base will give you the height, which is also diameter. And you divide by 2 get the radius. Okay, so that's one way of doing it. Now there's another shortcut. Okay, what you do is using the ratio. Okay, so for example, when you have a circle inscribed in a polygon, okay, so what you do is you can use the ratio. So what you do is this. Okay, so area of a polygon over perimeter of the polygon, okay, will equal to area of the circle over perimeter of the circle. Okay, so use a ratio. So area of this one we just figured out, so it's 432 the perimeter is 4 times that, so it'd be 24 square root of 13, right? Right over here, right? Okay, equal to area of the circle. That's what you're looking for. Okay, well actually, so area of the circle is pi r squared, and area and the perimeter of the circle is 2 pi r. So when you cancel things out, you can see 432 over 24 square root of 13 is equal to, so this cancels out, so r over 2. Okay. So here's kind of your shortcut. So if you want to memorize these, okay, so this will equal to r over 2. Okay, if you do that. Okay. But if you don't remember the r over 2, just go and derive it. Use your ratio. Okay, similarity, right? So you can area over perimeter equal to area over perimeter, and you can reduce that. So from here you can see that radius equal to, this can reduce. This will equal to, if you look from here, right? This came from 18. So it will give you 36 over square root of 13. And from here you can figure out your pi r. Don't worry about simplifying these. Okay, so area equal to pi r squared. And you can multiply out. And so this will give you 1296 pi over 13. And you can put this over here. Okay.
Matthew Barrett, to the upper school office, please. Matthew Barrett to the upper school office.
Okay. And this kind of problem shows up quite often because if you look at 93, 94, they like to put this kind of problems up here. See, here's another one, right? So it's the same thing. So you can use a shortcut. A over P equal to R over 2 shortcut. You can figure out the radius very quick, and you can figure it out. Okay. So try to memorize this part over here. A over P equal to R over 2. Okay, now when you go to 95, the 95, 96, if you look at, again, look at the strategy to figure out this over here, right? So you have this semicircle plus this semicircle, then plus a triangle, and you minus this over here. So you have to kind of keep track, okay? So again, this area equal to this plus this plus this. That's the whole thing, right? See this over here, this is a semicircle, this is a semicircle, and plus a triangle. So this is this entire shape. Then you minus this big semicircle. So you can develop your strategy, and then don't figure out individual. Notice this half circle and this half circle equal to what? Equal to one circle, right? So that's pi r squared. That will give you one entire circle. So learn how to move things around. So when you put these two half circles together, this is a complete circle. Then you minus and you plus the area, so it's 1/2. So turn this sideways this way, right? See over here. So area is 1/2 base times height, so it's 1/2, right? So 1/2 base times height, and minus this big semicircle, so it's 1/2 pi r squared, right? And then after you work it out, okay. Again, when you're doing this C problem over here, notice that it can develop your strategy. So this area equal to a circle minus the 12 segments, right? Because there are 6 cat eyes, right? Each of the cat eye equal to 2 segments. So area equal to circle minus 12 segments. And then from here, area of the circle is pi r squared. And the segments, right, is 12 times. Now segment is this over here, see over here? It shows you, right? So it's a sector. This is a sector minus the triangle, okay? And then you work it out. But remember to distribute, okay? And you work it out. So you can develop your strategy first, draw out the shape, and then you can work from there. Okay, so notice over here, here's another problem. Again, it's a C problem, right? So it shows up many times, right? So they like to put a circle inside the rhombus. So make sure you study this. Okay, it shows up many times. Okay, another thing is, another type of problem you're going to see a lot is when you have two circles. Whenever you have two circles, you need to draw a trapezoid over here, and then you have to divide it into a rectangle and a triangle, and use Pythagorean theorem to figure out all the parts. So again, this type of problem shows up a lot. So make sure you know how to do this kind too. So work it through. Again, notice, break down the strategy. Right? So you go to this little the arc over here, and you have this one here, right? So break into parts, and you figure out each one individually. Okay. So you have this problem over here. So this is 2001, 2002. So if you move things around, right? See, if you move this to this corner, this area, the shaded region, actually is equal to a square minus a circle. If you move these things around, okay. So if you cut this and move around, so this is equal to the square minus the circle, okay. If you're looking for the area, okay. In case if you're looking for area, but this one is looking for the arc. So you just use this times by 4, right? So it's 2 pi r, that's entire circle, and you times by 1/4 to get one of them, and there are 4 of them, you times by 4, okay? But again, so in case if they give you this picture and they ask you for the area, then what you do is you cut into 4, move it around, so this becomes a square minus a circle, and you can figure it out. Okay, again, over here, this kind of problem, this one kind of shows up often too. Okay, so again, there are 6 cat eyes, so equal to 12 segments. So each of segment is equal to a sector minus a triangle. Okay, so you just, the area is pi r squared times 60 out of 360, right? And the area of each of these is 1/2 base times height, and you can figure it out. So you have to know your spatial triangles. Okay, this one from 2003, 2004. Again, it shows up. So this over here. If you move things around, if you cut and move, see see the arrow? It shows you cut and you move, right? It becomes this. So how you figure out this? Well, you're gonna have this big square minus the inner square, and that's your answer, right? So you can learn how to move things around when you have this kind of picture. Okay, so get used to this kind. Okay. Again, you can see how each piece is moved, right? See the arrow? Just follow the arrow. It becomes like that. Okay? I think we run out of time. Okay, let's go and stop.